This will be projectile problem number 3 from worksheet number 2. We have a building whose height is unknown. In fact, that's what we're trying to find. What information is given? The information is that a projectile, a ball, is kicked off of here and it lands 75 meters away. That's nice information to have. We're also told that the initial velocity is 25 meters per second and the angle is 52 degrees. That's it. We're not given the time, and in projectile motion problems, time is usually very useful. We don't have it right now, at least given. So we need to find the height. What equation is going to bring it all together with the information we have to find the height? If you think about it, probably equation 5. Okay, well, don't get that confused with, this is problem 3, worksheet number 2, 2/3, okay? But anyways, equation 5, y is equal to y0 plus vy0t minus 1/2 gt squared. Now, I always start my problems with the beginning point, the beginning position being the initial position, y0. And then this would be y, the final position. You could say this is y0 being 0. This is like 0 meters. And this is y. You could do it, flip it around like that, but it doesn't matter if you're consistent. I just like to start my problems with my initial position being the starting point. Okay. Then this equation here, if we bring y0 to the other side, we have y minus y0 is equal to vy0t minus 1/2 gt squared. And this y minus y0 really is the difference in height, so that is h. But if you think about it, y being a small value, probably 0, and y0, if you subtract those, you really have you're going to have a negative number. So this h, this quantity here is going to be negative. So let's just keep that in mind. But I'm going to start by saying then h, and I'm going to go ahead and put a negative h, is equal to vy0t minus 1/2 gt squared. And that's equal to, now what's vy0? vy0 is the initial, this is vy0. It's the vertical component of the velocity, and that is 25 sine of 52 degrees minus 1/2 g, I'll say it's 4.9. Sometimes I say 5. In other words, g is either 9.8 or 10. And so some deviation from my answers will be seen if I originally solved it using g is equal to 10 versus 9.8. So I'm going to use 9.8 right now. Doesn't really matter. T squared. All right, so that's negative h. Okay, now the problem is, whoops, I need to put in a t here. There we go. Don't forget the t. But we don't have t, so what's t? Well, time is equal to distance over speed. In this particular case, we're going to consider the x part, because the time that it's in flight is the time it takes to move 75 meters in the x direction. So that time is 75 over 25 cosine of 52 degrees. And if you plug that into your calculator, you should get 4.87 seconds. So that's a great thing to have because we've got the rest of the equation. So let's go ahead and finish it off then. So negative h is equal to 25 sine of 52 degrees times 4.87 minus 4.9 times 4.87 squared. And if I'm doing this right, that should be equal to 95.9 minus 116, and that gives you basically minus 22.7. So since that's minus h, we have that h is equal to 22.7 meters, and we have solved the problem. Thank you very much.